Welcome to another deep dive. And wow, this one is really exciting. I've been looking over all the research that you guys send in about supermassive black holes and how galaxies evolve. And I've got to tell you, some of this stuff is mind-blowing. So to help me unpack all this, we've got an expert here.
I'm really looking forward to getting into this. It's some pretty cutting-edge research from the James Webb Space Telescope that's giving us new clues about, how supermassive black holes actually shaped the galaxies we see today.
Yeah, and one thing that's really got my attention is this area they're looking at called the Spiderweb Protocluster. It's almost like, a time machine going way back to when the universe was really young.
Yeah.
So can you paint a picture for us? What exactly is this Spiderweb Protocluster all about?
So, well, imagine this. A huge city, but instead of buildings, it's packed with galaxies, right? It's this massive cluster of galaxies that's just starting to form, and it's unbelievably far away, about 11 billion light years, which means, the light we're seeing from it now, it actually started traveling toward us when the universe was still a baby.
So we're basically getting a glimpse of, like, the universe's construction zone way back when.
Yeah, exactly. That's a great way to put it.
That's amazing. And what kind of galaxies are we seeing in this protocluster?
Well, lots of them are what we call giant elliptical galaxies, which are kind of like the senior citizens of the universe. They're full of old stars, and there's not a lot of new stars being born in them anymore.
Now that you mention it, I was reading that elliptical galaxies are kind of mysterious, so these huge galaxies, but they're not really making new stars like other galaxies, are they? What's the deal with that?
Right. Yeah, that's a great question. And it's been a bit of a puzzle for astronomers for quite a while, because you see, galaxies are supposed to be like these bustling nurseries teeming with new stars. There's all this gas and dust that's supposed to collapse under its own gravity, forming new stars and keeping the galaxy alive and vibrant. But in these giant elliptical galaxies, something seems to have put a stop to that whole process.
I'm sensing that that's where these supermassive black holes come in.
You got it. Yeah, the research you sent in suggests that these supermassive black holes might be the culprits behind why star formation is stalled in these galaxies. And it's not just about them, gobbling up all the gas and dust, although they definitely do have a pretty big appetite.
So if it's not just them eating all the ingredients for new stars, what else is going on?
Well, imagine you've got this supermassive black hole sitting at the center of a galaxy. As matter falls into the black hole, it releases tremendous amounts of energy, right? And that creates these incredibly powerful jets and winds that blast outward.
So like a cosmic hurricane ripping through the galaxy.
Yeah, that's a pretty good analogy. These outflows are so powerful that they can heat up the surrounding gas and dust, making it way too hot and spread out to collapse and form new stars. It's kind of like trying to make a snowball out of steam.
So it's not that the black hole is directly eating all the star-making material, but it's more like it's creating a kind of galactic sauna, I guess you could say, where stars just can't form.
Exactly. That's a great way to think about it. And the James Webb Telescope is actually giving us the evidence to back up this theory. Researchers have been looking at individual galaxies within this Spiderweb protocluster, and they've found something pretty remarkable. The massive galaxies that have actively feeding supermassive black holes, they're showing almost zero signs of new stars being born. It's like their growth has been completely stunted.
So what clued the researchers into this link between the black hole activity and, the stunted star formation? What were they looking for in the James Webb data?
Well, one of the key indicators is how bright the centers of these galaxies are, the really bright ones. That means the supermassive black hole at the center is actively feeding, it's pulling in huge amounts of matter and blasting out massive amounts of energy.
And I'm guessing that when they zoomed in on those galaxies, the ones with those super bright centers, they didn't see a lot of new stars being born.
Exactly. And that's the fascinating part. We used to think of supermassive black holes as mostly destructive forces, but it turns out they might actually play a crucial role in regulating star formation and shaping how galaxies evolve.
I've got to say, this is really changing the way I think about black holes. So we've got these supermassive black holes blasting out energy, heating up the gas, and basically putting the brakes on star formation. But what happens to all that energy? It can't just disappear, right?
Nope, you're absolutely right. All that energy, it's got to go somewhere, and it can have a huge impact on the whole galaxy.
So it's not just messing with star formation, but these black holes are actually shaping the whole galaxy. Tell me more. I'm hooked.
So remember those super powerful jets and winds we were talking about? Well, they don't just vanish, you know. They travel super far, carrying energy and matter way beyond the black hole itself. It's like a cosmic shockwave rippling through the galaxy.
Wow. And what kind of effects do these shockwaves have on things?
Well, think of it kind of like redistributing wealth, but on a galactic scale, right? These outflows carry heavy elements, the stuff that's made in the hearts of stars, and they spread it far and wide. It enriches the gas and dust throughout the whole galaxy.
So even though they might be shutting down star formation in some areas, they're actually helping new stars form in other places.
Exactly. It's like a delicate balance. And sometimes these shock waves can even trigger new star formation themselves by, compressing gas clouds and kickstarting that whole gravitational collapse process.
It's like these black holes are less like cosmic vacuum cleaners and more like galactic gardeners or something. They prune some areas, but then they help seed others.
That's a great way to put it. But wait, there's more? Remember those giant elliptical galaxies we talked about? Well, their unique shape. That might actually be because of supermassive black holes, too.
Hold on, you're saying that those smooth, oval-shaped galaxies are actually sculpted by black holes. How does that even work?
Well, it all comes down to galactic mergers. Galaxies, you see, they don't just exist in isolation. They bump into each other and collide over billions of years.
Oh yeah, I've seen those incredible pictures, galaxies colliding. It's like a cosmic ballet or something, all those stars and gas swirling around.
Yeah.
But I always thought those collisions were super violent and destructive.
They are definitely dramatic, but they're also a key part of how galaxies evolve. When galaxies collide, everything gets mixed up, stars, gas clouds, the whole shebang. This can trigger these huge bursts of new star formation. And it can also send a ton of material toward the supermassive black holes at the centers of the galaxies.
So the black holes basically have a feast during these galactic collisions.
Yeah, exactly. And as they gobble up all this matter, they grow even bigger and their gravity gets even stronger. And that increased gravity can start to mess with the orbits of stars and gas clouds, pulling them out of their original paths.
So it's like a cosmic blender, reshaping the whole galaxy.
I like that, a cosmic blender. And over billions of years, this gravitational sculpting can transform the shapes of merging galaxies. They might have started out as spirals or irregular shapes, but eventually they get smoothed out into that elliptical form.
So those giant elliptical galaxies we see today, those could be the leftovers from multiple galactic mergers, with the supermassive black holes at their cores shaping them into what they are now.
Yeah, that's the leading theory. And we can see evidence of these mergers all over the universe, like distorted galaxy shapes, these long streams of stars and gas, they call them tidal tails, and even pairs of supermassive black holes orbiting each other at the centers of merging galaxies.
Man, this whole picture of galactic evolution, it's just incredible, so dynamic and complex. It's kind of mind-blowing to think about all these processes happening over billions of years.
And we're really just beginning to scratch the surface. The James Webb Space Telescope is giving us such a clear view of these events, and that lets us piece together the story of the universe's evolution in more detail than ever before.
Speaking of evolution, I remember reading that our own Milky Way galaxy is actually on a collision course with another galaxy.
That's right, the Andromeda Galaxy. It's our closest big galactic neighbor. And in about, 4 billion years or so, our two galaxies are going to start this long, slow dance of merging.
Wow, that's both amazing and, kind of scary. What's going to happen to our solar system when that happens? Are we going to get, flung out into space?
I wouldn't worry too much about that. It's really unlikely our solar system will be ejected. The distances between stars are so huge that direct collisions are super rare. But our night sky is going to go through some pretty spectacular changes as the stars from Andromeda and the Milky Way start mixing together.
I can't even imagine what that would look like.
Just imagine, instead of just one band of stars like our Milky Way, you'd see two whole galaxies intertwine, their spiral arms blending together, creating all these amazing new patterns of light and color.
Yeah, that would be an awesome sight. And what about those supermassive black holes at the centers of our galaxies? What happens to them when the galaxies merge?
Now that's where things get really interesting. Over a long period of time, those two black holes will slowly spiral towards each other, getting closer and closer. Eventually, they'll merge, forming one giant black hole.
I bet that merger would release a ton of energy.
You're telling me. The energy released when two supermassive black holes merge is like one of the most powerful events in the entire universe. It sends these ripples, called gravitational waves, through space-time itself.
Wow, it's hard to even wrap my head around something that powerful. Makes you realize just how tiny we are in the grand scheme of things.
It definitely puts things into perspective, doesn't it? But it's also incredible that we can actually study and understand these processes, piecing together the story of the universe's evolution, from the smallest particles to the largest structures.
I've got to say, this deep dive has been a real journey. We've gone from baby galaxy clusters to galactic mergers, from star-killing winds to the future of our own galaxy. And supermassive black holes seem to be right at the heart of it all. And it really makes you wonder if these supermassive black holes are like the ultimate galaxy sculptors, right?
Yeah.
I mean, could they also be the reason why there are so many different types of galaxies out there? You've got your spirals, your ellipticals, your irregular galaxies. It's like a whole cosmic zoo.
Yeah, that's a great question, and astronomers are really working hard to try and figure that out. I mean, we've been talking a lot about how supermassive black holes help create elliptical galaxies, but their impact probably goes way beyond that, affecting other types of galaxies too.
So it's not like a one-size-fits-all situation. These black holes, I mean, they can have different effects depending on the type of galaxy and like where it is in the universe.
Exactly. It's all this complicated interplay between different factors. You got the mass of the black hole itself, how fast it's eating up matter, how much gas and dust is in the galaxy, even whether there are other galaxies nearby. All of that can have a huge impact on how a galaxy evolves.
It's like some kind of cosmic recipe or something. You change up the ingredients, you get a whole different galactic dish.
That's a great way to put it. And that's what makes studying galaxies so exciting. You're constantly discovering new things, making new connections, and getting a better understanding of like the whole cosmic picture.
Yeah, this deep dive has been amazing. But I've got to admit, I still have tons of questions. Like we've talked about black holes and galaxies, but what about dark matter? Does that play a role in this whole cosmic dance too?
Ah, dark matter. The invisible force shaping the universe. It's definitely a big part of the story, and it's really tied up with how galaxies evolve and how supermassive black holes behave.
Yeah, I remember reading that dark matter is like a huge chunk of the universe, but we can't even see it. Kind of creepy, right?
Yeah, it's definitely a little mysterious. We can only tell it's there because of how its gravity affects stuff we can see, but we know it's out there, and it's doing important things. Think of it like this. Dark matter halos are like the scaffolding that galaxies are built on. They provide the gravitational pull that draws in gas and dust, which eventually clump together to form stars. And that whole process, well, it eventually leads to those supermassive black holes forming too.
So dark matter sets the stage, and then the black holes come in and like take over the show.
Yeah, in a way, that's a good analogy. The gravity of dark matter helps determine where galaxies form and how they interact with each other. And then, as the galaxies evolve, those supermassive black holes at their centers, they start to flex their muscles and shape the galaxy's fate.
It's like this incredible cosmic dance happening on a massive scale with dark matter and supermassive black holes leading the way. And we're lucky enough to watch it all unfold, even though we're still trying to figure out all the moves.
Totally. Every new observation, every piece of data, it all helps us understand this incredible cosmic choreography a little bit better.
Well, this deep dive has definitely given me a whole new perspective on supermassive black holes. I mean, they're not just these cosmic vacuum cleaners sucking up everything in sight. They're architects, they're sculptors, they might even be gardeners, shaping the universe as we know it.
And with amazing tools like the James Webb Space Telescope, I think we're going to keep uncovering even more incredible things about these black holes and how they shape the universe.
It's a universe full of wonder, and it seems like every time we find an answer, it just leads to more questions. But I think that's part of what makes it so amazing. There's always more to explore. So to everyone listening, keep looking up, keep asking those questions, and keep diving deep into the mysteries of the cosmos.